Gonna have to rock with it, bro. Gonna have to rock with it. What? Okay, let's see. Okay. Okay. All right. So you're given an array of strings tokens that represents arithmetic a valid arithmetic expression in reverse Polish notation. Return an integer that represents the um valuation expression. The operands may be integers or the results of other operations. Okay, so this is a stack problem. What's the recommended time and space complexity? Okay. Okay, so you have if it's plus, minus, multiply, or divide, we want to check if well we want to pop two values off of the stack. Um, okay, okay, and if it's an integer, if it's a digit, just push onto the stack, push onto stack, and then have a variable that stores the Q. I don't think you need to have a variable, to be honest, because the final value will be at the top of the stack, right? Final value will be at the top of the stack. So for let's see, stack, let's go to for token and tokens. If token in plus minus times divide, um, we want to pop the top two. So now one, I'll just do like x is equal to pop, y is equal to stack dot pop. Um, so stack push append. Um, stack dot append. Int x plus int y, right? Else stack dot push token return int stack 0. See if this works. Oh, and token doesn't work. Okay, so we have our stack push 1, push 2, C plus, so we're gonna pop, so we get 1 plus 2, which is 3. Um, wait. No, that's not the. I do. Why? You don't want to add necessarily. How do you map a? How do you map a? Plus. Okay, so you can do import operator, then let's go to plus add dot what sub, and then okay, so right? No? Oh, cooked. Okay. All right, that works. Let's see. Um, Reverse Polish. Why is it in C++? Wait. Okay. Submit. Okay, that's good. Daily temperatures. You get a jacket, correct? Daily temperatures. Mm, given an array of integers. Okay, so okay, so say you have 30, 38, 30, 36, 35, 40, 28, right? Now, these are the temperatures. Okay, it could be any of these. Okay, so I think this one where you need to have the stack in order. So like an monotonically increasing stack. So you can have like, say 0. So this is index 0, right? Right. Then that's the first one. So we don't know um what's larger than that, right? So we go to index 1, which is 38, and 38 is larger than, so while 38 is larger than the top of the stack, um whatever's on the top of the stack, the you basically take, so 38 is at index 1, so you do like 1 minus x, where x is the index for the for a certain day, uh, for a certain previous day. And so you would just set result x is equal to I minus x, right? That's what you would use. And if and then afterwards you would just push I onto the stack. So once you're done popping, you would push I onto the stack. So you would push 1. Then once you get here to second index, you'll check, okay, is 30 larger than the top of the stack? No. So you would just do push 2 on here. Is 36 larger than 30? Yes. So you would pop 2, right? So you would be like result 2 is equal to um result 2 will be equal to, what is it? 3 minus 2, which is 1. Um and then you would pop, you would check again. 36 is not larger than 38. So you would just push 3 onto the stack. And then once you get to the end, whatever remains inside your stack, you basically set the result of that index to 0 because there's no value, there's no index in the future from that specific date that's going to have a higher temperature. So, um, let's see. So we can have like stack, right? Then stack temperatures 0, right? For I in range length 1 comma wait, 1 comma length temperatures, right? Um, okay, so you do that, and then if while temperatures while stack and temperatures I, right, is greater than temperatures stack I, wait, no, stack minus 1, 0 times um length temperatures um and then what you do here, so while stacking results stack 1 is equal to I minus stack -1. And then you just do stack dot pop, right? And stack dot append temperatures I. Wait, no, stack dot append I and return res. So basically, daily temperatures stack temperature 0. No, we want to just put 0. Just want to put the indices, right? Then for ion range length, pretty sure this is fine. Yeah, this is fine. What? Okay, let's see. Okay. Okay. Car fleet. Um, let's see. Car fleet. Actually, hold on. Okay, let's see. Car fleet. There are n cars traveling to the same destination on a one-lane highway. You are given 2 arrays of integers. Position, You are given two arrays of integers, position, speed, both of length n. You are given okay, so we have we know position and speed, right? And they are arrays of length 1, 2, all the way to n. Speed I. Okay, so target. Okay, so okay, so car cannot pass another car ahead of it. Can only catch up to another car and then drive at the same speed as the car ahead of it. So what is it? So the only way you can catch up to a car and ahead of you is if you're moving at a faster speed. Um, but then when you catch up to it, your speed becomes that car's speed. A car fleet is a non-empty set of cars, same driving at the same position and same speed. Okay, so car fleet is basically they're side by side at the same position and same speed. If a car catches up to a car fleet, the moment the fleet reaches the destination, okay, the number of different car fleets that will arrive. Okay, so this is asking how many groups there is going to be. So if we have target 10, target, let's go to 10, position 1, 4. So we have pos equal to 1, comma 4, and speed equal to 3, comma 2, right? So let's just say we have a, then you have, so 0, 1, 2, 3, 4, target. Target is going to be out here somewhere. So C1, wait, yeah, car 1, and then 1, 2, 3, 4, so C2, right? This is going at speed of 3, 3, right? So okay, so 3 miles per hour, 2 miles per hour. Um, so 1 mile, 4 mile. So in an hour it will catch 3 and 2. So 2, 3. So C1 will be here. C2 would be 1, 2. And then so C2, and then 1, 2, 3. C1, and then, oh no, 2, 3. And then C2, and 1, 2, 3. So, wait, let's draw this again. We have C1, okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So C1 starts at position 1, so here. And then C2 starts at position 4, 2, 3, 4. So it jumps 3, so 1, 2, 3, C1. And C2 will jump 2, so C2. And then C1 will jump 3, 1, 2, 3, 1. C2 will jump 2, so 1, C2. C1 will jump 3, 1, 2, 3, and then C2. Okay, so it catches up at the last, at the target, right? And fleet. Okay, but it doesn't explain why, or um, so the target is at 10. Um, how can we use the stack here though? Um, monotonic stack. So, um, wait, is the should you sort the? I feel like you should sort the position. Hmm. See. How do you determine that though? So you put one into the stack, right? And then you're like, and then four comes along. Um, four comes along. So it's just 1 plus equals to 4 plus 2x. So we're setting their okay, so if position P1, P2, um, and then speed 1, speed 2, you set those equal and you solve for x, right? And you get x equals 3. And then if You can take either one of these, right? Plug it back into, right? If 1 plus 3x is less than target, they're part of the same fleet. So you can push, I feel like you can push a tuple here, right? You can push 1 and 3. And then so once you come across a position, I'm thinking like monotonic stack. So let's just say you had a third position and speed value. Let's say you had position 5, P3, 5, or no, 6, maybe 6, and then speed is 2, 6 plus 2x. This becomes 0 is equal to equal to 2, which is false, right? So it can't be part of the same fleet. Um, so we clear the stack here, make a value here. Can you solve something like that in Python? Um, can you, if I had, let's see, okay, so I can do like stack is equal to this, and then for I in range length position, um, not stack dot append, um, I comma speed I. Okay, so model stack, and let's see, what do we want to check? So if res equal to 0, so if the one, C comma D is equal to position I comma speed I, and then what I can do is x is equal to C minus A comma D. Then what you can do is int. Just make sure it's an integer. Um, hopefully. B is the position. So if they're the same speed, f equals B. If it's the same speed, right, then and they're different position, there's no way that's gonna catch up. So stack dot there, and then res plus equals 1. Um, and C comma D. Continue. If what is it? If C X is the target. If it's like if it's reachable, wait, you only need one. This is probably wrong, but hmm. Maybe you should break here. I think we need this. So okay, now basically, mm, 2, 1. I tripping. Okay, so let's see. Target is 10. We have 4, 1, 0, 7, right? Position. And then speed is 2, 2, 1, 1. Okay, now the reverse stack. Since it's empty, we're gonna put 4, comma 2. Four comma two, brother. 4 comma 2, right? And then so A, B. And C. Hmm. 2. Okay, so CD is equal to 1, 2. If B is equal to D, right? So okay, that's not enough. B is equal to, so 6, 8, 10, 3. It's not going to catch up. So CD. So it's going to be 1 comma 2. So res is equal to 1. Then 0, 1. So they're not equal. So C minus A. Mm, hmm. Is it 1? So it's what? Hi. Hi. Yeah. Okay. I'm gonna come back to this tomorrow. Can end the stream.